One reason we want to know how to evaluate functions is it will help us evaluate something called the difference quotient. Now, if you're not going on to calculus, you'll probably never see this. But in calculus, this is a big deal because the difference quotient is actually the way we calculate the slope of a secant line. What's a secant line? Well, this curve here is my function, and all these little lines here that are touching it just 2 times, cutting through it, that's called a secant line. So if I have an x-coordinate here, I go a little bit further up, call that x plus h. Then I look for what's the y value associated with each of those. In this first case, it's f of whatever it is, so f of x. In this case up here, it'd be f of the x plus h. So now I have 2 ordered pairs that are on my function and also on that secant line. So if you remember, the slope is the difference in the y's over the difference in the x's. So f of x plus h minus f of x, yep, that's what I have there, over x plus h minus x. Well, the x's are going to cancel and we have just the h. So that's what this weird looking thing is actually calculating, is the slope of that secant line. And when we make h smaller and smaller, we're approximating the slope of something called the tangent line that just touches in one spot. That has some interpretive meaning, and I'll let you go on to calculus to get into that. But just know that it's not just a crazy formula. So let's see if we can actually apply this to a specific problem, if I can get that to go away. All right, so if I want to find the difference quotient for f of x equals 4x minus 1, I have to find f of x plus h. F of anything means you take that stuff and put it in place of the x. Not multiply by it or anything, you put it in place of that x. So this x is going away and I'm putting instead x plus h. So that's where this first bracket of stuff comes from. Then it says minus f of x. Well, that's exactly what we were given, so that should be pretty easy. Don't forget those brackets. And then it's always all over h, so that's an easy part. Now to distribute, here I'm going to change some signs. I'm going to have to multiply in that first one, and then I look through and notice that I have some terms that are going to cancel, and I reduce down to 4h over h, but then again I can reduce a little further and get a simple answer of 4. Well, if we remember something about lines, we know y equals mx plus b, so this number here in front of the x is our slope, so it shouldn't be too shocking that our answer was 4, because that's the slope of the line, period. The problems become more interesting if we have more complex functions. So let's look at f of x equals 3 minus x squared. So this is a quadratic. If I graphed it, it would be a parabola. Same process. F of x plus h minus the f of x that we're given, always over h. The first part is really the only somewhat tricky part. So we're going to take x plus h and put it in place of this x. So that's why it says 3 minus and then the quantity x plus h squared. Minus straight up f of x, whatever we're given. Again, don't forget those brackets, all over h. In a previous video, we talked about when you square something, it does mean that you're multiplying it by itself. So you can't just individually square these things. You actually do have to work it out, okay? And you will get a trinomial. X plus h times x plus h, FOIL it, you get a trinomial here. Keep it in parentheses, right? Figure out what this is, and then we're going to subtract all of it. So all of those signs are going to change. Just like here, I had to change these signs. So then I, again, have things that cancel. That's always going to happen with this. And when I reduce that down and divide everything by h, I get a simpler expression, negative 2x minus h. So this is telling me the slope of that secant line is going to vary depending on where it is, where it is along that graph, what that x value is. Let me know if you have any questions.